Good morning everyone. In last class we studied the energy of electron in an isolated atom and energy of an electron in a combined atom, that is a solid, and how that solid structure is made by combining many isolated atoms. Now we studied types of bonding. The first one here we are studying the ionic bonding. In ionic bonding, we consider an example of NaCl, that is a sodium chloride. The atomic number of the sodium is 11 and the electronic configuration of the sodium is here as per the formula, that is we know 2n square. Based on this 2n square formula only, the electrons are going to occupy in the each orbit. If you put n is equals to 1, that is equals to 2. So 2 electrons in the first orbit, and if you place if you put n is equals to 2 for the second orbit, so that is 8 electrons in the second orbit, and finally the remaining 8 plus 2, which is 10 now, but the atomic number is 11. So 1 electron is going to present in the third shell, that is a 2 in first, 8 in second, and the final last one is a 1 electrons in the outermost orbit. 2, 8, 1 electrons are distributed in the shells K, L, M. Here we are naming the shells as a K, the first shell as a K, and the second shell as a L, and third shell as a M. So how the electrons are distributed, that is by the formula, that is 2n square. 2 electrons in the first orbit, 8 electrons in the second orbit, and the remaining 1 electron in the third orbit. Why? Because the atomic number of the sodium is 11. Similarly, chlorine. The chlorine atomic number is 17. The electronic configuration of the chlorine, so as per the same 2n square, by considering the 2n square formula, if we place n is equals to 1 into n square, the 2 electrons in the first orbit and 8 electrons in the second orbit, and the remaining 2 plus 8 is 10, and remaining 7. So 7 electrons in the third orbit. So 2 plus 8 plus 7, which is nothing but 17 is the atomic number. Based on that atomic number, the electrons are going to occupy in the first shell, second shell, and third shell. The electrons are placed in the orbit by the formula, that is 2n square. If you see this electron distribution in case of sodium, the outermost orbit is having 1 electron, and in case of chlorine, the outermost orbit which is having 7 electrons. 7 electrons are present in the chlorine, and 1 electron is present in case of sodium, that is over here. But if you refer the second point, valence electron in sodium is 1, and it needs to lose 1 electron from the outermost orbit to attain an octet. There are many methods of stability for an atom. The one method here we considered is the octet rule. What it says, based on the octet rule, in the sense, if the outermost orbit, if it is having 8 electrons, then that particular atom is a stable atom. But if you refer this sodium, the outermost orbit is having 1 electron. But in the case of chlorine, the outermost orbit is having 7 electron. So in order to form a octet, that is 8 electrons in the outermost shell, so this sodium, what it will do, it will give 1 electron to the chlorine, so that the electrons which are present in the outermost shell of this chlorine is now 8, and the electrons which is present in case of a sodium, if it loses 1 electron, means the second shell is having 8 electrons, that is this shell. this shell is having 8 electrons. Now if it gives this 1 electron to the chlorine, means the outermost shell is having a 8 electron. Now we can say the sodium is stable now. Similarly, if we consider the chlorine, if it takes a 1 electron from the sodium, now the electrons which are present in the outermost orbit is 8. Now this is also stable. This is nothing but a covalent bonding. If you refer the periodic table, here the atomic number of the sodium is 11 and the atomic number of the chlorine is 17, and here the sodium is highlighted with the orange color. That orange color is nothing but a alkali metal, and here the chlorine is represented with the help of a sky blue color, that is nothing but a halogen. Here alkali metal and a halogen material is combining. NaCl we are combining. If Na, that is atomic number of the sodium, is 11, but it gives 1 electron to the chlorine, now the atomic number of the sodium becomes 10. So 10 atomic number corresponds to, if you refer this periodic timetable, 10 is nothing but a neon. It's a, that is given with a brown color, that is nothing but a noble gases, that is mentioned over here. If you refer this color pattern, respective color pattern, that is nothing but a noble gas. Similarly, now the sodium loses 1 electron and it acts like a noble gas, that is neon. And chlorine, now the chlorine, it takes 1 electron from the sodium. Now the atomic number of the chlorine becomes, chlorine atomic number was 17, but it takes 1 electron from the sodium and the atomic number now it becomes 18. So 18 corresponds to argon. Now chlorine acts like a argon and sodium acts like a neon. So what it was before? Before they were a alkali metal as well as a halogen. By after losing as well as a gaining electron, they become a, they are showing the property of some other atom, that is nothing but a noble gases. So that theory part is given here in a handwritten slide, that is 2n square. If you put a n is equals to 1, means the first orbit is going to take a 2 electron. That is, if we consider a sodium, the first orbit it is having a 2 electron. Similarly, second orbit, if you put n is equals to 2, means 2 square, which is 8. So 8 electrons are present over here, 8 electrons, but the atomic number of the sodium is 11. So 8 plus 2, which is 10, already 10 is over now. Now if we put n is equals to 3, means the third shell is capable of taking 18 electrons, but our sodium atomic number is 11. So as per that, it is going to 1 electron is going to place in the third orbit. The third orbit is going to have a 1 electron as per this rule, that is 2n square. Similarly, we follow the same rule for the chlorine also, but as per the octet rule, what it says, then atom is going to stable only when the outermost orbit is having a 8 electrons, then it is a stable. So as per that rule, it one extra electron is present in case of a sodium, and a chlorine needs 1 electron to form a 8 in the outermost shell, that is nothing but a NaCl is formed. This is the electronic configuration. This is our electronic configuration of sodium, that is 1s2, 2s2, 2p6, 3s1, and chlorine atomic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. This we already studied in our school as well as in our PU also. So the neon atomic number is 10 and argon atomic number is 18. So sodium acts like a now neon and chlorine acts like a now argon. So Na plus and Cl minus is a good insulator. Why I am referring it as a good insulator means there are no free electrons at all. In case of a sodium, the outermost shell can occupy 8 electrons and that 8 electrons are present. But in case of a chlorine also we have 8 electrons in the outermost shell. There are no free electrons at all for the conduction purpose. Conduction is only possible when we have a free electrons. When a flow of electrons is nothing but a current. Here there is no free electrons at all, so it is a good insulator. So pictorially again with the help of the picture it is explained here. That is a outermost last configuration is mentioned here. This is 3s2, not 3s1. This is 3s2, 3p5. How Na symbol, why we are representing it with a Na plus and Cl minus. See, in ionic bonding, an ionic bonding is the attractive force existing between the positive ion and a negative ion when they are brought into close proximity or a surrounding. Here if you refer the diagram, that is clearly mentioned over here. The atomic number of the sodium, the outermost electron is transferred to the chlorine, and now chlorine become a positive ion and chlorine become a negative ion. See, ion, as name says, they are converting themselves to a positive ion as well as by gaining as well as losing an electron. So that's why this is an ionic bonding. These are the properties of an ionic bonding. These ionic bondings are rigid, unidirectional and crystalline in nature, and they have a high melting and boiling point. Ionic solids are a good insulators of electricity in their solid state and a good conductor of electricity in their molten state. Ionic solids are soluble in water and slightly soluble in organic solvents. So what we are considering here is the chemical materials, chemical compounds, atoms we are considering. So they show different properties upon giving temperature, by applying an electricity, or by in a molten state or in a solid state. They show different properties that we have to consider, because whatever we are studying here is a semiconductor devices as well as a chemical materials we are considering. So they show different properties. They don't have a constant property at all situation. So they show different properties at different situation. So this is a covalent bond. A covalent bond is a type of a bond where they are not transferring the electron, they are only sharing the outermost electron. So that one is explained with the help of chlorine. What is the chlorine atomic number? The chlorine atomic number is 17. So as per the 2n square formula, 2 electrons in the first orbit, 8 electrons in the second orbit, the remaining 7 electrons in the third orbit. So here this is nothing but a third orbit. So third orbit is having a 1, 2, 3, 4, 5, 6, 7. If we consider an isolated single 1, 2, 3, 4, 5, 6, 7. So 7 electrons are present in the outermost orbit. But this is a covalent bonding. As per the again octet rule, what it says, when the outermost orbit, this outermost orbit, when it have a 8 electron, then it is a stable. So for that stability purpose, so rather than transferring, they will share the electron. So that electron is present in that particular atom as well as with the neighboring atom also. Here we are not transferring. In case of NaCl, what happens? The sodium is giving a 1 electron to a chlorine, but here the both chlorine are sharing a common electron for a stability purpose. This is nothing but a covalent bond. Here also the 8 electrons in the outermost orbit. Here also we have 8 electrons in the outermost orbit. That's why this is a stable now. This one is for a same element. We can consider even a different metals also, like a water. So if we consider a water, how it will be? The atomic number of hydrogen is 1. In the first orbit is going to have a 1 electron. Similarly, H2O, 2H molecules, 2H atoms we are considering. So this H. And oxygen, the atomic number of oxygen is 8. So in the first orbit it is going to take a 2, in the second orbit it is going to take a 6. Why 6? Because atomic number of the oxygen is 8, 6 plus 2 which is 8. So 2, 2, and here we have a 6 electrons in the shell, particular shell. So when we combine that one, that we are converting that to a water, when the combination occurs, what happens? As per the octet rule, oxygen wants 8 electrons in the outermost orbit. So for that reason it will share a 1 electron, only sharing 1 electron with the hydrogen and another electron with the another hydrogen. Now the outermost shell is having 8 electrons. Now oxygen is stable. Similarly, we can say the hydrogen is not having 8 electron, but can we say it is a stable, or we can say it is as a stable, as the atomic number of the hydrogen is 1. So we cannot place 7 electrons in the first orbit, but the first shell is capable of taking 2 electrons as per this 2n square formula. So the first shell, if you put n is equals to 1, maximum can be taken in the first shell is 2. So first shell is having a 2, in a sense it is also stable. So how this non-similar metals as well as a similar metal, how the covalent bond is formed, that is shown in this slide. That is water molecule and with the chlorine molecule. These are the properties of a covalent bonding. Covalent compounds are bad conductors of electricity. Covalent compounds are having a low melting and boiling points. They are soluble in water, soluble in organic solvents like benzene. Third type of a bonding, which is nothing but a metallic bonding. So metallic bonding is nothing but a metal. You imagine a metal where a sea of electron, here they named it as a sea of electron. Sea of electron in the sense there are many free electrons in that type of a material. So they are ready for the conduction, like aluminium, gold as well as the copper. They have many free electron. As soon as by applying external field or by increasing the temperature, the electron starts conducting in that particular metal. So that's why the by considering a cost as well as by considering the efficiency, the copper is nowadays copper is used as a material for the current carrying purposes. These are the properties of metallic solids: high thermal and electrical conductivity, low melting and boiling point temperature, have bright luster. Metallic solids are malleable and ductile.